example 1 in 8.3 for Math 30-1 gets us to use these log laws. And one of the things that's going to make this, ever easier is to try to limit how much you do in one step. And really what I mean by that is when I am manipulating log base 5 of x times y over z, I am going to deal with the kind of numerator and denominator first, and then if the numerator is more complex, which it is, we'll deal with that after. So the initial log law I'm going to use is right away I'm going to deal with the division. And log base 5 of a numerator divided by a denominator becomes log base 5 of the numerator, which is x times y, minus log base 5 of the denominator. Now, because it wants it in individual logarithms of x, y, and z, I can't just leave it as log base 5 of x times y, so I need to go one step further, and log base 5 of x times y will turn into log base 5 of x plus log base 5 of y, and then our negative log base 5 of z is still there. Now, obviously I went through that kind of quickly, and really all I've done here is I've split the fraction first, and then any product within a logarithm I've split after the fact as well. All right, the other thing that comes up in this question is an exponent rule that maybe you don't remember so well, and what it is the nth root of a variable is that variable to the power of 1 over the index of the root. And the reason why I bring that up is you cannot use the power log law unless there's a power, unless there's an exponent. So when I look at log base 7 of the cube root of x, initially it looks like I can't use any of my techniques. But if we remember that, exponent rule from Math 10 and 20, I'm going to rewrite this as log base 7 of x to the power of 1/3 as the argument. And that immediately, I hope, makes it, a little more obvious that we can use our power log law, because the exponent is 1/3, so that exponent is going to become the coefficient of our logarithm. I cannot stress how important this one is. If we had to identify, one log law that we should prioritize, change of base is close, but I still do think that the power log law is more useful. We are going to see it as a very, very useful tool for solving exponential functions, because if the exponent is a variable, this allows us to change it from an exponent to a coefficient, which makes it solvable. And we'll see that more in chapter 8. Okay, I split these other two onto another page just so we could do them separately. There is 2 ways of doing C, and I actually want to do both with you just to make sure we see that, sometimes there is another technique. I'll do probably the most obvious one first, which is I'm going to change it to the log base 6 of the numerator minus log base 6 of the denominator. All right, log base 6 of 1 is 0. Log base 6 of x squared can be written as 2 times log base 6 of x, so that is negative 2 log base 6 of x. That's the typical way, I would say. The other way of doing this is recognizing that 1 over x squared can be written as x to the negative 2. I'll do this one in black. That means that I can write log base 6 of 1 over x squared as log base 6 of x to the power of negative 2. Well, log base 6 of x to the power of negative 2 using my power log law is negative 2 times log base 6 of x, and we get the same answer either way. If I was going to do this, right now I think in red is a more useful technique, but certainly what I wrote in black is just as valid of a way to do it. All right, the last one here is the most complex, which is pretty typical, I think. We have the log base 10, not that it really matters, of x cubed over y times, and I'm going to write right away as z to the power of 1/2. Now, I'm going to try to be consistent with how I've done this. If you look back at how I did example A, I dealt with the fraction first. So the first thing I'm going to do is I'm going to rewrite this as the log base 10, same base, of the numerator minus the log of the denominator. Now, what's really important about this is I cannot use the power log law unless there is a single expression to that power. So my first logarithm can be changed into 3 times log of x. My second logarithm can't, because only the z is to the power of 1/2. The y is to the power of 1. So because they don't have the same exponent, I can't pull that entire exponent out. So what I'm going to do, and I'm going to put a square bracket around here, is I'm going to deal with the product side of things first. So this is going to be the log of y plus the log of z to the power of 1/2. That negative should be applied onto both of these logarithms. So this is 3 times log x minus log y minus the log of z to the power of 1/2. And the last thing I'm going to do is my powered log law, and I get 3 times log x minus log y minus 1/2 log z. And this is definitely a good place to talk about how I always put that bar on my z's so I don't get confused with my 2's. That is a relatively difficult one for sure. The common mistake that students make is they don't do this step where they distribute the negative. Really, really important that because y and z were in the denominator, they really should be a negative logarithm. And that's a pretty consistent concept across. Using these techniques and these log laws, I really can't overemphasize how much practice is required. The more you use them, the easier they get.